Hi everyone. This is the explanation of my code for the semester end project. So here I have been creating on neural network from scratch. So this is the explanation for that. So as you can see here, I have been importing the libraries, and here is my first dense layer. So the every dense layer gets initialized by the number of the inputs it has and the number of neurons it wants to have. The layer has, and the weights have been randomly initialized for each neuron, and they have the dimensions of the number of inputs multiplied by number of neurons, and the biases have been set to 0 initially. And in a forward pass, what do we do is that we have a dot product of the inputs with their corresponding weights, and we add the biases to them. And then I have put it out the railway activation function. So what this function does is that it takes out some input and it gives the maximum of that input and 0. So the railway activation function is an important function because it helps us to code the non-linearity in the neural networks. And here is the softmax activation function. So this function is used at the end to predict the class probabilities. So here we have the normalized probabilities, and we normalize them by dividing it by the sum of the expected values, exponentiated values, and the output of this particular activation function will be the probabilities. So here is a simple loss function. So basically a loss is calculated upon the output and the y, and once we have the sample losses, we calculate the total loss will be the mean of all of them, and that is our data loss. So the way it is calculated is like you have to, as you can see here, this is a categorical cross entropy. So what this means is that you have to assign the confidence score multiplied by the correct class to which it actually belongs, to which our data actually belongs, and you have to take the negative log of that and sum of all of that. So that's the loss categorical cross entropy. And here I have created out a simple spiral data set which is of 100 samples per class. So there are like three classes. So there are like 300 samples and 100 belonging to each of the three classes. And we have created out a first layer which has the 2 as an input features and 3 neurons. So in short, 3 output values. And there's an activation function, first activation function. And then I've created out a second dense layer which takes in 3 input and gives 3 as an output. So as you can see, the dense layer 1 will give its output as an input to the dense layer 2, and the number of the outputs are same here as the number of the inputs in the second dense layer. And last one has the output has 3, which is actually this is where I have to end it on. So basically the 3 will be actually giving me the class probabilities belonging to each of the classes. So at the end I have to use soft activation function, softmax activation function to classify, and finally to calculate the loss I have used the cross entropy. So finally we forward pass the training data into the first layer, and then we apply the first activation function which is the ReLU on that, and then we pass it to the second layer and we apply the forward pass to that, and finally we we see the outputs of the activation function. So as you can see, the outputs I have run here, they are like assigning each point to approximately equally to all of the 3 classes, because right now we haven't set the weights properly and it is randomly initialized weights. I'm very sorry about that. Actually the idea is that we have randomly initialized the weights here. That's why they have been assigning the outputs almost equally to all of the 3 classes. And finally we are calculating the loss function because of the activation and this loss function of the outputs and the actual values, and there is our loss. So one of the key things to update the weights are like you can iterate over some iterations, and you can iterate some iterations and randomly initialize the weights and choose the weights which actually give you the least error, least amount of loss. Or otherwise, you can just randomly subtract a small fraction of the weight from each of the weights, or reduce them by some particular fraction, and see if it actually gives you better results or lesser loss or more accuracy. And but both of the ways actually fail. What you can do is that you have to do a kind of back propagation methods, which I aim to implement. And there are other things like optimizers and dropouts, and that's all. And we have to test this on fashion minist dataset that I have looked into to test upon it. So far, I have been able to do this much only because of the I have been tested positive with COVID-19, so I have just not been able to code for the last few days. But I plan to continue it in the next semester itself, or probably in the summer. I am going to look at the how to implement these networks very efficiently. That's all from my side. Thanks for watching.